Hello everyone. Today we are going to be working on simplifying rational expressions. So this is part one. This is just the first time that we're doing this. We will be getting a little bit more complicated later, but we're just starting off for today. So first of all, a rational expression is the quotient of two polynomials. So that's why we did our factoring review yesterday, because we're going to use all of that stuff. So to simplify rational expressions, there are three steps. Step one, factor the numerator and denominator. You cannot do anything until you have factored it. Step two, reduce monomials as normal fractions. So if you have a monomial over a monomial, for instance, if you had something like 4x over 16, if we thought of the fraction 4/16, we could reduce it to 1/4. There happens to be an x in the numerator, so it'd be like 1x over 4. If you had something such as 9y squared over 18y, 9/18, first of all, reduces to 1/2. And if you think of your exponent rules, y to the second over y leaves us with 1y in the numerator. So that's just the reducing of the monomials. Now to deal with the rest of the polynomials, the only thing you can do with a binomial or a trinomial is if there are matching binomials or trinomials in the numerator and denominator, they reduce to 1. It has to be an all or nothing thing with binomials and trinomials. They either match and they reduce, or there's nothing you can do with them. So let's give this a try. So problem number one. The numerator is just an 8, so I'm going to leave that alone. The denominator has a GCF, so I'm going to factor out that GCF. The GCF is a 2, so if I factor out a 2, I would have then 2x minus 1. So the only things that I can actually reduce are these monomials, because you can only reduce monomials with monomials, binomials with binomials, and trinomials with trinomials. So if I were to reduce those, 8 and 2 reduce to 4 and 1. So we have a 4 in the numerator, and there's a 1 in the denominator, but if I were to distribute it, I would still have that 2x minus 1. That binomial of 2x minus 1 cannot be reduced with anything else because there is not another binomial that exactly matches. So that's all you can do. You cannot reduce that 4 and that 2 because the 4 is a monomial and the 2 is part of a binomial. Okay, problem number 2. So in the numerator, it's just a monomial. We're not going to do anything with it yet. In the denominator, we have a binomial that has a GCF. It happens to have a GCF of just a variable x. And if we reduce that out, it'd be 3 plus x. So that binomial on the bottom, again, we can't do anything with it because there isn't a matching binomial. Leave it alone. If you wanted to write it as x plus 3, totally fine. Now, the monomials, the x's match, and anything divided by itself is 1, so we can cross those off, which leaves us just with a 6. And again, that's 6 and 3. One's part of a monomial, one's part of a binomial. It cannot be reduced. I cannot stress that enough. Problem number 3. So sometimes you're going to be coming across a problem you have to do a little bit more than just a GCF factoring. So for that numerator, if I thought of two numbers that multiplied to 9 and added to 6, that would be 3 and 3. So I have x plus 3 times x plus 3. The denominator has a GCF of 3, so I'm going to factor that out as x plus 3. Now if I look at what I have matching binomials. These two go to the anything divided by itself is 1, so it is gone. What's remaining is a binomial of x plus 3 in the numerator and a monomial of 3 in the denominator. And that is as far as you can go for that problem. Problem number 4. The numerator has a GCF of 7, so I'm going to factor out a 7. So 7 times x minus 2. Now if I look ahead at this problem, the denominator says 2 minus x, not x minus 2. It's backwards. So one of the things you can do if you need to flip over a binomial is factor out a -1. Because if you factor out a -1, the 2 would become negative and the x would become positive, essentially switching it, flipping it over. And now I have matching binomials, which can be reduced to 1. And 7 divided by -1 is just -7. So if you need to flip over a binomial, factor out a -1. Okay, last problem. If we had trinomials in the numerator and denominator, so for the top, we're trying to figure out two numbers that multiply to 15 and add to 8. That would be 3 and 5. So we would have x plus 3 over x plus 5. Now we're trying to figure out two numbers that multiply to -12 and add to -1. That would be a -4 and a +3. So I'm going to write my x plus 3 first, just so things line up, and my x minus 4 second. And I now have two x plus 3's that I can reduce to 1, leaving me with x plus 5 over x minus 4. So we have to factor first, reduce monomials with monomials, reduce similar binomials to go down to a 1, same trinomials also reduce to a 1, and so on. So just a common error reminder, something like x over x plus 3 does not equal 1/3. This is a common error. The common error is going, oh, I can reduce those x's. No, you can't. One's part of a monomial, one's part of a binomial. It does not work. So you cannot reduce a monomial with a binomial. So today's word of the day is rational. Part of rational expressions. So we are dealing with rational expressions. So we're going to take that first word rational and make it our word of the day. So your assignment is going to be simplifying rational expressions part 1. So simplifying rational expressions part 1. So you're going to be looking for a part 2 on Monday. And it is due Friday, March 27th. Okay, if you have any questions, let me know. Have a great day.